Have you ever really stopped to think about how you can watch a video streamed from a server halfway across the world on your phone while you're on a bus? I mean, it feels like pure magic, but it's actually all made possible by a set of invisible rules that run the internet. So, let's dive into the two most important rulebooks, TCP/IP and the OSI model.
Yeah, let's start with that big question. How in the world does your phone have a perfect conversation with a server that's thousands of miles away? What allows these two totally different pieces of technology running completely different software to understand each other without a single hiccup?
Well, the answer is a shared rulebook. It's a common language. In the world of networking, we call these rulebooks models or protocols. They're the reason every device, whether it's your laptop or some massive data center, follows the exact same steps to send, receive, and understand information. Honestly, without them, the internet would just be pure chaos.
All right, first up, let's talk about the OSI model. The best way to think about this is like a perfect, super detailed architectural blueprint for a network. It's the grand vision of how everything should fit together, designed with amazing precision, where every single function has its own place.
And this blueprint is neatly organized into 7 distinct layers. Now, each layer has a very specific job to do, and it only communicates with the layers directly above and below it. This layered approach is actually brilliant because it makes it so much easier to troubleshoot problems and really understand the whole communication process, from the physical wire all the way up to the app you're using. So here's the key takeaway about the OSI model. It's a conceptual model, a reference model. It was developed by the International Organization for Standardization, or ISO, to try and create a universal standard. It's really more of a theory, or a guide, an incredible teaching tool for understanding how networks work.
And this quote just sums it up perfectly. The OSI model explains how data should flow. In a perfect world, it's the ideal standard, the ultimate guide for network engineers. But, and this is a big but, it's not what's actually running the internet day to day. For that, we need to go from the blueprint to the engine. And here's that engine. If OSI is the flawless blueprint, then TCP/IP is the powerful, practical engine that was actually built, put on the road, and proven to work. It might not be as theoretically perfect, but wow, it's the workhorse that powers the entire internet.
Right off the bat, you can see a major difference. Instead of 7 layers, the most common version of the TCP/IP model gets the job done with a much leaner structure of just 4 layers. It basically combines some of the OSI model's jobs to be more practical and efficient.
And this brings us to another key idea, protocol suite. You see, TCP/IP isn't just some concept on a whiteboard. It's a whole collection of actual, real-world protocols that are built into every single internet-connected device you own. We're talking about things like TCP, IP, HTTP. These are the actual tools that make things happen.
And this just perfectly highlights the difference with OSI. TCP/IP doesn't just theorize about how data should move, it defines how data actually flows across the internet that we all use every single day. It's the practical, functioning reality of how all this stuff works.
Okay, so we've got the blueprint, and we've got the engine. Now let's put them side by side and really dig into the key differences between this theoretical ideal and the practical reality that we live with.
This comparison really lays it all out, doesn't it? On one hand, you have OSI. It's a conceptual model mainly used for teaching and understanding. And on the other hand, you have TCP/IP, which is an actual protocol suite used in the real world. OSI explains how data should flow. TCP/IP defines how it actually flows. If you take one thing away, it should be that difference in purpose.
Now look at how these layers actually map to each other. You can see how TCP/IP just consolidates things. It takes the top 3 layers from OSI, the application, presentation, and session layers, and just bundles them all into a single application layer. It does the same thing at the bottom too, merging the physical and data link layers into one network access layer. It's just a much more streamlined approach.
And where they came from tells a huge part of the story. The OSI model came from a standards organization, ISO, that was focused on creating this universal, all-encompassing standard. TCP/IP, though, it was developed by the U.S. Department of Defense for a very practical project, ARPANET, which was basically the grandfather of the internet. So one was built for standardization, the other was built for implementation.
So the theory is great and all, but let's talk about how this TCP/IP engine actually powers the things you do online every single day. This is where it all becomes real.
The TCP part of TCP/IP stands for Transmission Control Protocol,
And you can think of this protocol as being completely obsessed with reliability. Its entire job is to make absolutely sure that all the little packets of data that make up your email or a web page arrive safely, without any errors, and in the right order.
So how does it guarantee that? Well, before it sends even a single piece of data, TCP does something called a three-way handshake. It's a really simple but absolutely crucial little conversation. The sender basically says, "Hey, can we talk?" The receiver replies, "Yep, I'm here and I'm ready." And then the sender confirms, "Awesome, the data's on its way." Just like that, you have a reliable, stable connection.
Think about an app you probably use all the time, like WhatsApp. When you send a message, your phone is using protocols like HTTPS that live in the top layer, the application layer, of the TCP/IP model. This layer is what gives your app the ability to talk to the network.
And the TCP/IP toolkit is just packed with these essential tools. HTTP and HTTPS, that's how you browse websites. SMTP is the protocol that sends all your emails. And DNS, well, DNS is basically the internet's phone book. It's what translates a website name you can read, like google.com, into an IP address that computers can actually find.
So when you boil it all down, the internet we know and love was built on TCP/IP, a practical, efficient, and super resilient model that was born from a real-world project. It's not the perfect 7-layer blueprint that OSI imagined, and that leaves us with a really fascinating question. If we could start all over again today, knowing everything we know now, would we build a more structured OSI-like internet, or would practicality and good enough win out all over again?